In your machines, open a terminal, click on CD tools. Okay. Ls, you will have this SURVOS, and then /SURVOS. It will take a little bit while. SURVOS is a multi-platform software, so you could be installed in Linux, Windows, or Macintosh. That's a nice thing to have. As you can see, it takes a while. It's implemented in, yes, here we have. You probably have all this window. You can open a dataset or load a workspace. We will use it if we had a problem with our machine, or we have a problem with our with the servers that is sometimes not so stable. You can always recover the last thing you have done. Go into this load workspace button. But let's start in. So let's go to open dataset. You should be there. Home Scipion data, segmentation, demo data. And you will have this. In this case, you will see it's a cellular tomogram. Okay, they will be easy for you to recognize all the features if you are more or less used to play with a cell. So let's go this, open. It will load into the memory of the software. Yeah, and you will see there's a nucleus, mitochondria, some networks inside, and you will see here there are cells growing on quantifoil film, as you will see. You can play a little bit and play with different views if you want. Okay. It's not necessary, but it's necessary to go for this workspace folder. Okay, we are going to select a new folder for that. So here in demo data, we are going to create a new folder. It will be nice to have this new folder, call it SURVOS or whatever you want to call it. Something good, because all the files that the SURVOS will generate will be there inside. You will not mesh up with all the different things or filters that you want to use outside SURVOS. And there will be the folder that we are going to use in recoveries when we want to recover SURVOS workspace. So now everyone have this. Okay, so let's go into load, and we'll open this. Okay, if you play here in this window, if you play with the wheel of the mouse, you will see the whole volume up and down. Okay. You will see that also there's some parts of a tomogram that are not really needed for segmentation, and as much as possible you can reduce the size of a volume. It will be nice for segmentation. You don't need 32 bits, or you don't need bigger sizes. So you can bin it, you can go for 8 bits, and it will be easy, easier for that. Then you can apply the mask that we are going to generate to the volume that you want. But to play with this and to save memory and to make things a little bit more faster, it will be nice to have it like this. Okay, as small as possible. But even here, you can play with that. So we are going to this tab. You see here some visualization. So there is a ROI, the region of interest, and then there's some theta, x, y from 2 and x. And we can try to play a little bit with this. And first go for theta. So I mean, it doesn't make sense to play with a volume bigger than that. So first value of theta is 41. So we can put here 41. Go to the other part of the tomogram in theta. It doesn't make sense to go for a volume bigger than 170, sorry. 178, for example. And then it's also sometimes interesting to try to trim a little bit this type of artifacts. Sometimes it doesn't matter of you, but there are some lines that are not so nice. So here, for example, if we are going, if you see the numbers here, okay, I'll go. If you go for this slice up and down or with the wheel, you will see that it's more or less nice to trim the volume at this level. So if we see the numbers up to the right, you will see that X will be, the value of X will be 460. So we can go to X 460. And if we go to the other part, I think this doesn't make sense to trim too much. Maybe just a little bit here, for example. So it's going to take 10 pixels from this part. Yeah, I hope that everyone more or less are understanding what I'm doing. I'm going just to go for the limits of the region that we are going to use in XY coordinates. So, and let's try to trim just 1 pixel, 5 pixels here. And we don't need this part of this of the other cell that are here. You see. So we can trim. If you see, if we have a look on the top right, we see that the value of the cursor, and it's about 400 and let's say 55. 455. Okay. We add these values, and if we click here, it will show you the region of interest. But they are just showing you have still your full volume here or full volume here. So there's a trick. So there's a trick that you can use in order to save memory or to be focused here on this software. Is define several region of interest. So let's think for a while that you are interested on this part. Okay, only this part. So it's not necessary to go for it. So you can segment all this part, and then if you want, you can segment the rest of the volume like that. So let's try to figure out that. So if we go for these coordinates and X, we are going to see is about 45. Now in X, we are going to go in 45. Y, we are going to define is the 260 in this case, more or less. And in Y is 270.
But for us.
You can say for training purposes.
Yeah.
Hello?
But we are not going.
170, sorry, and 400 here. It's 400, 400 here. So then we can find a very small region. You see? Or we can go for it if you want. That's nice if you have a big volume or your computer is not so power. That doesn't have so much power. There's a trick that you can use. So segment all these parts differently, all this region of interest, as in order as you wish. That's a trick that you can use. So let's gonna choose this one or the one that you choose. Okay, these values or the value that you want. Okay. To tell you, the volume is still there. This is just showing these parts, the ones, the pixel or the voxel that are between these values. So go for the next one. Let's go to feature channel. What is feature channel? So let's see. I didn't open this. Yes. You have all in the documentation that they put in. in the course, there is a lot of filters and tricks that you can use under this software. Threshold, embedded threshold, Gaussian filter, local variation, all these things can be used to extract or to enhance the values that you want. For this type of data, I play a lot with this. The best things that works normally is you can use a Gaussian filter. So apply the filter that you want.
I have a question,
Yeah.
Javi, here.
Yeah.
So all these tools, they substitute, they replace the original tomogram, or they create a kind of extra layer that you can use to help the segmentation?
It creates an extra layer. It creates extra volumes that you want to use, could be able to use if you want.
Okay.
We'll see it later. They will create the filtered volumes, and you can filter in cascade mode, so in recovered mode. So first you can use filter, then with this filter you can use another one or not, or go it back to the first one. And depending of the thing that you want to filter or you want to enhance, you can play with different ones. So if you want to go for a nucleus that is so big and easy and rounded, you can apply some filters. If you need to go for these tiny membranes, you can use another filter. You know what I mean? So it's quite flexible in that case. So
Okay.
you can always come back and forth to create the labels or create the masks. Okay. So once you have this selected, add is here in the available channels, and you select it. You see here, go back. I normally prefer to use the clamp. Clamps, it's a way to make a little bit more robust the filter. Otherwise, it will go a little bit out of it. But this is a matter of trial. So I normally prefer to go for clamp and to make it more fixed to the original data that you have. But if you want the filter to go further, that and click on this and it will go. So just for an example, doesn't go for it. If you click on this tab, it will go.
So I'm sorry, Javier,
Yeah.
could you please repeat how you get this panel that's called Gaussian filter?
Yeah, sure. Close it here. Here in this list, click here. You see? And you have a huge amount of filters.
It's probably my problem. My internet today is not stable, so you like hanging. So okay, I'll just restart and come back. Thanks. Sorry.
I'm sorry. So again, Gaussian filter, add. Okay. You can click here to select all this one. Go down to have these extra values and go for it. And you see this filter. It's good. Can I just go for see clamp? Relaunch it. And you will see that it's not so much for this Gaussian filter, but you will see that it's a little bit more similar to the data. If we go for a bigger sigma like 10, let's have a look on it. You see? But if we clamp it, in this case, it's not so easy. There are another ones that are more visible. Anyway, as you can, it's just a matter of play with it and play with the filters. And play with the filters slowly, so you can have time to go for it and feel comfortable with this filter. Normally you will have the values that on the doc file here. Go here. Okay. There's the values that you can use. But also there's here is 5 2 2 2. You can go for execute it again. As you can see, it refresh all the time, unless click here and let's choose the one that it's normally works better for this type of tomograms. Total variation, and then just add another channel. It's like in fluorescent microscopy. You can choose different labels if you want, but it doesn't matter how do you use it. And now in CLAMP, you will see that you have two possibilities: data or Gaussian filter. So that's one I told you. You can use different filters one after the other, but you can also try different ones and create different layers. I don't know if you really understand more or less how the feature is going. Here it uses it. Okay. Here. Okay, you can go for data. Give it. Okay. You see that now here these boundaries are a little bit more sharp. And the density inside of it one is more or less constant. That's the thing that we normally want in that case. So for this type of filter, here there are some values that you can use in the document. So spacing 1, lambda 20. As bigger the lambda, as similar the volume will be to the standard one. 20 here, and you see that it's less dramatic to filter. What is the limit of that? I told you it just depends of you and the feature and your tomogram and what you want to have. Because things here you can now on this window. Okay. You have all the possible visualizations. So the Gaussian filter, total variation. See that the Gaussian filter is nice, but the boundaries are much more straight here. So that's something normally better for that purpose. So I give you some 5 to 10 minutes to play with it if you want. There are a lot of things that you can use. We know about the eigenvalues. Add this one, and then go here. Just try to go for this, for example. Click on this, and you have this. This is nice. Well, probably if you want to cement some membranes, it's nice. But you've lost most of the feature that you want. Why it's necessary for this type of volume? As I told you, this or these are the best one. But I will show you just an example of some membranes. Here, if we use total variation, is totally meshed. But this is much more enhanced when you use a local centering, for example. So it's a matter of play with filters, take some times. And once you have it, go for it. And it doesn't matter because you will be always be able to go back and try another one if the next step will not fit. Okay. Is everybody
Sorry,
okay?
Javier.
Yes.
One question: do you know if, because there's a similarity to what we do in the image processing, we do segmentation to identify vesicles, basically membranes.
Yeah.
And I guess the software has some ways to do the same thing.
Yeah, it is.
Do you know if there's a way to interact with SURVOS? So are these filters available through command line, or?
It should be there. This Anaconda and Python, so it should be there and easily. And the files that they create is HTML file, HTML5, so it's easy to interact. In fact, we have some Python scripts to extract the data from SURVOS and calculate volume distances and surfaces from different amount of volume. So yes, it's something that will be great to be able. Yeah.
Yeah. Thank you.
Is everybody more or less okay with this filtering? Should I go to the next super region thing? You're also playing with filtering. It's just how to play more or less with this software. So let's go for the next step. So is what is this? Okay. What's Supervoxels? What means that? We are going to go for it. So we have an image. We are going to create this type of, let's say, artificial big aggregation of voxels. Why we want to go for that? To make our life easier. Okay, if you have one tomogram to play with, it's not too much, maybe, but if you have some hundreds of one, you need to be fast. Otherwise, you need to select your mask every layer, so every voxel in zeta or in X, whatever you want, and it takes time because you all normally have several hundred of pixels in zeta. So we need to create some big things with the boundaries as good as possible to be able to segment here the big thing here, or the heart, or the mustache, or the face. Now it's here just 1, 2. We will have the full face mostly, but here we will have a lot of voxels to play with it. This software defines two types of aggregations. They call it megavoxels and supervoxels. With the megavoxel, it's like this. It is not easy to go for it. It tends to go too much for the artifacts in the borders, and it's not easy to use it. But if you want to go for whole cell or nucleus, yeah, let's make some trial. Makes sense to try if you want. I normally just stuck on the super voxel stuff, and it's what we are going to show you. So let's go back to the volume that we have. Let's go here to the super region tab. Okay. Here, super region tab, and then we have the super voxel and the megavoxel. Okay. How to play with it? Yes, we need to be careful because it tend to crash if we apply too much values to this one. So then you can go for this, for example, and let's go see what happens. Use just the values by default. Yeah, and it creates all these things. You see here the blue lines. Yeah, there is some loop that you want to use. So there's an aggregation of several voxels here. And if you play up and down, you will see that these super regions also extend to the normal. Here you go for the whole volume again.
Maybe, Javi, you have explained, but what is the difference between supervoxel and megavoxel?
It's a different way to, it's second order, as they call it. Here, let me show you again. The software define it in as an aggregation of pixel second order region. It's just how the threshold is defined.
But the megapixels are computed on the superpixels, or
No. This is a different way. You will see it.
Okay.
That's a different way to play with it. Also, here, if you go to this tab, you make this line, blue lines, more or less visible. It doesn't matter if you wish. Also, you can play this value. You will see that, well, it's not so useful, this segregation. You will not see boundaries and everything. So maybe we need another way to go for it. Yes. With shift and left click, you go back to the magnification that you want. It's not centering today. I don't know what happens. Okay. Also, you have again the layers. All the layers will be appeared here. What's another possibility? Instead of this, go for this total variation and apply. And then instead of the original data, it will use the filtered volume to compute. And now you see that it's pretty different. Okay. And now if we go this, you will see here the line for the nucleus. So it's not necessary to click or to be able to select all the voxels here. Just to click on this voxel, it will automatically go for this boundary. Okay, so it makes our life easier. And even more, we go up and down here. Here, you see that the supervoxel, whatever it wants, it will stand in theta. So it's just not 2D. It will stand in theta, following the boundaries that we are going to create. So this is a nice thing to have and to make our life easier. So let's to make even easier. Let's go for values. Let's go for this. So shape, let's go to 5, 5, 5, compactness 20, apply. Yep, and even you have this. So even it will be easier to, but maybe it's too much. So let's go for 3, 3, 3, for example, apply. What happens is sometimes you put a number and the computer takes too much time to go for it and it just crashed and you need to recover from the very beginning. You see that now here there are some smaller features. So it's up to you, but for this course, I recommend to go for a bigger stuff because we are not worried now to be accurate. Yes, I wanted to show you tips and tricks. Okay, so go for a bigger one to make our life as easier as possible for a moment. And now here again, go for the data. You always can have a look on the real data to make your life easier. And what thing to do? You can go for biggest supervoxels at the very beginning to cement big things, but you need detailed thing. You can go back to this tab, generate a different supervoxels, smaller ones, to just go for tiny stuffs. You know what I mean? So it's flexible, and you can go. Well, the same with the filters. You can go back and forth. Let's say have a look a little bit on the supervoxels. So let's go for Gauss total variation here. And let's try apply. and it will have, it's just the red stuff. Let's go to this, and you will see it. So it's not that bad. There are some big one, too bad, some less structured here. But the problem of this is it will, as I told you, is this the same with the other. It will stand in theta. So as you can see here, all these lines will distort a little bit too much. And you wanted to select the nucleus here, and it will stand up and forth, and even sometimes go to this line, this big supervoxels, megavoxels in this case. So you can use it; it will work. Mostly the same as it worked for supervoxels, but it's normally not so nice. It's a different way to aggregate voxels with similar boundaries or similar densities. So you are more or less okay with this?
Sorry, Javier. We
Okay.
forgot to create the breakout rooms, although we haven't used them much, but probably it's good to have them in case we need to assist some of the users.
Yeah, maybe someone stuck
So
from this point. Yes.
I can ask Blanca. Remember to click on close. Okay. Don't join any room. That way we have the rooms. Okay. I'm not sure if Blanca is actually listening. Done?
Done.
Really?
Yeah, you can see the overlap. Then the way to play with this is this. So you can show it or not showing here in the visualization tab, or just makes transparent, or just it's the same. You can see the value or just don't want to see it. It's a matter of you.
Okay, since everyone is here, great. Except Javier, what happened? Oh no, he joined he joined the room. Can someone go and rescue Javi, please?
Blanca, could you please?
I can make you presenter.
Okay, good, thanks. I'm back again.
You should be able to present now.
Yeah, it's okay.
Yeah.
Okay. You're right with this. This is a feature that you will need to go for it so often, because sometimes it's nice to see the boundaries, sometimes not. Here, do directly on select stuff, and here you can see how transparent it is. Also, you can here define if you want the data, Gaussian, or total variation. I normally prefer to segment in data to see the real data, but it's a matter of what do you want. Okay. I'll put this just in case you want. Okay. It is more or less okay. Just go for the next step. And that's the annotation layer. Okay. You got it? And here is where we are going to create all the masks that we are going to apply to our data. So what's the meaning of level and everything? So there's sometimes, let me show it is here in the document. We have a mask, we have an image, and we are going to create a binary mask. Matrices, there are black and white, are 1 or 0. So if you multiply these images to these images, 1 will be still keep the original values, but 0, this dark side, will be return this pixels to 0, to value 0. So when you go for these images, you will have a segmented images. And this we want to do it, and we are going to create this mask manually, or more or less manually, or going that way. Okay. And by default, once this pixel, the pixel that we have here, is assigned to this level, okay, to this circle, let's say, it will be assigned to the circle. It will not be assigned also to this one. So in how can do in the case that we can assign a voxel to 2 different things? Yeah, it's possible. So the voxel here will be nucleus, but also will be cell. This will be a mitochondria. It will be mitochondria, but it will be also cytoplasm. And how to do with that? Because otherwise, if you select cytoplasm and then you create another mask for cytoplasm and then another one for mitochondria, the mitochondria selection will be erase the cytoplasm selection, and we don't go for that. To avoid this problem, we can create different layers or levels. Okay, is what is there. Okay. So if we are going to select cytoplasm or cell and nucleus, we can have cell, we can have cytoplasm and nucleus, and then we can have the organelles in 3 levels. So we can add level, click in here, add level, we can create a level like cell, and type here the name that you want, click here and select the value that you want. Okay, just to make your life easier. It will be not, it's just for visualization, because every single layer will have their different value, and the mask is a mask. So we can add another level, a label inside that will contain, for example, the nucleus, or another label inside this, level that is cytoplasm. Okay, click here to select the color that you want. Okay, and another one. That one, if you want for for example, mitochondria. Okay, or let's go for red. And another one that could be vesicle. Okay. That could be yellow. We can define this structure. My advice, it doesn't, if it will be just one cell, just one tomogram that you want to go for artwork, you can do whatever you want. It doesn't matter. We will see later how this can we be able to extract this data out. But if you want to make some numbers inside and compare different cells, different things, the best thing you can do is to keep all this the same for all the cells that you have. So it's sometimes better to think it a while and to take some time to think about the levels, the labels, or the things that you want to segment. You just
Can you, Javi, can you
Yep.
save the levels and then load the levels in another tomogram? The definition of levels.
it will be nice. No, it's something that you need to have in your print screen, and then when you open a new one, apply it.
Okay.
That's the. It will be nice to have it. I mean, probably if you go deeper on the Python scripts, the Python software, you can try to trick SURVOS to go for it. But for the moment, the best thing to do is just to have in your mind, to have the draw in your close to the desktop, and or just print screen to remember exactly the position and the name, also the name that you could put here. This name will be saved into HDF file. Okay, and you can go for naming. So let's go for all the labels that call it mito, and then measured volumes, and then extract data from that.
And another question. So these levels will be used to create a mask. So
Yeah.
in the mask file, the values associated to the mitochondria, vesicles, or whatever, are they fixed, or can you fix them somehow?
The values.
Yeah. So for instance, vesicle will have value 5 and mitochondria value 4, or you cannot
You
change
say
that.
no. It will be in the name. In fact, you will see it later. All the structure that we have here, level 0, we will have a label 0. Level 1 will have a label 0 and 1. Level 2 will have label 0 and 1. You know, and the name of the label
Okay.
will keep this structure.
Okay.
So that's the way it works. So the problem of the name that we are going to extract will keep this nomenclature, but it will not follow the name that you put. It will not. You cannot give the name a different. I mean, when you extract it, we will see it. You will not give. You will not have the name. This name, but this name will be inside the HDF5 file that SURVOS use it. You know what I mean? It will be extracted that way. So not only
Yes.
the numbers, but also the position and the name. It would be nice to keep the same if it's needed. Sometimes not. You know what I mean?
Yes.
It's a matter of the purpose that you have. If you wanted to get for this type of comparison, you need it. If it's just a matter of that you need one volume to make an artwork for something, then it doesn't make sense to keep this as you want. So just the thing that you need to know is if this voxel here will belong to the mitochondria only, or you want it to belong to a cytoplasm and cell. Okay. Then this voxel, how I prepare it here, this voxel will be able to be assigned to 3 different labels, 3 different levels. You know what I mean? But if I didn't create this structure, once I selected a voxel for a label, it will just be able to assign to only one, unless you create these levels. And that's something that you need to take into account. Okay. So then we have it more or less like this, and I think that we are going to give you 15 minutes or something like this to take a coffee. It would be nice, Pablo. Or we can continue. It's a matter of you.
Yeah, do a break if the schedule is okay.
Yeah, I think that because I need to. Then we will have time to use the pencil. So first now I think it's better to have 15 minutes or something to take a short break, and then come back with and start to paint.
Okay, so back in 1040.
Yeah, I think so.
Okay.
So there is some question related to the things that we are explaining. So levels, labels, filters, supervoxels, megavoxels. For this software, the supervoxel, megavoxel are not necessary. You can play without, but just are there to make our life easier. We will see it. Otherwise, you need to play to paint a lot. So one of the things that is normally nice to when you really go for segmentation of a lot of things is to have one of these things. So if you have, this is not, it will be easy to have a pencil or a tablet to easily, or even you have fingers, you can paint on your screen. It makes things easier when you need to. Wait, what happens with the display? I lost it. Yeah, I'm here back. Okay, it will make things easier. It's just a matter. You can do it with your mouse without problems, but you will see that sometimes it's better. So again, go back. How to do the segmentation? How to select it manually, and to define which things are nucleus, which are membranes, what things are, and more or less the tricks. So first, go for a cell. So let's go to select in the whole volume. You can know it still. You can play up and down with this, or with the wheel mouse. In order here, doesn't click, it will be erase the label. We don't want it to do that. But in order to paint with this, we need first to click it here to be able to select it. Okay. Then we click on pencil here, and once we click here, you will see it. It will appear some things. First, you can select the volume. So sometimes it's better to go for it. So we are going for the cell. So why not use total variation? That is even more easy to see the cell. And we have voxels here. This is the width of the pencil. See, big one, small one. Easy. Oh, how to erase it? Oh my goodness, how can you do that? Just click here and erase it. Okay, click here to select. Click here to erase. You see? Okay, so go for Supervoxel. You can use whatever you want. Normally go for linear one, interpolation mode. So let's go to select the cell. How to do that? There is a way to do that. Go for thicker thing. Oh, doesn't paint. Why? Yeah. You can do that. You will see it. It takes, if you try to do that, it's not be easy. Okay, to be carefully, let's go to avoid this. If you wanted to do that, it's complicated. With a pencil, it will be much more easier. This is not an easy task to do. Be accurately close to the cell. And if you go up and down, hey, it disappeared. Okay, you see the green label correspond to the cell is just on one plane. Okay, and this value of theta. We use voxels, so we are selecting voxels, and you see that it will take too much time to do that. Why we go for supervoxels? To be able to go for that. So if we can, supervoxels. Here, go for supervoxels. See it? If we now go to another plane and try to do the same, click here, supervoxels. You will see it doesn't matter. It will try to select the boundary because you are selecting this. Click. You see? Go click. How accurate it is? It depends on the size of the supervoxels. See, and now it's much more easier. You got it? You can play with this a little bit. You see what's different, no? By your own. And then with the wheel of the mouse, go up and forth. You'll see they are not restricted to one plane. The shadows gradient, you know what I mean? I don't know what I mean, Luca. I think that this is most of part of visualization. We are just painting. I don't know if you are going for 3D. This is not for 3D. This is just for creating the masks. So we have this. You see, go up and forth, and it will extend from this 55, go up, and almost 5 to 10. Okay. The supervoxels are in 3D, not like voxels that only is one layer. So what to do next? So we can go here, for example, or even less, and still going on. Oh, maybe it's too much. Control theta, erase things. You see? Or go here to erase, and it will go back. Click here to select again. You got it?
Yes,
See?
Javi, is there a reason why you are not drawing inside the cell? So I guess, is there later
Yeah,
a way to fill?
yeah, we are going to do the trick now.
Okay.
It's in purpose. See? You can do that. I'm selecting the boundary. The boundary is the most complicated thing to segment. Paint here is easy. You can go for bigger stuff here. Go back. The cell is here. So you can go for bigger things. You see how the black stuff will be trying to select. Cell is here. Cell is here. Here, and I'm moving theta. Cell is here. I'm doing the thing fast. Okay, it's for that it's time consuming. You need to be as careful as you want. Okay. And why I creating the boundary, only the boundary? Because there is a trick here down. Here, refine annotation label. Shen, cannot unselect the eraser. Yeah, click here and click here to be unselected. Okay. So there is a trick here. There's a lot of things that can be applied. There are multiplications and divisions that could be used to make your life easier if you know how to use it. First, fill holes. You don't need to fill up this. Go for fill holes, the radius where you want. This slice, so all the slices in 2D, and refine. Automatically fill up this. Oh, that's true. It's a good thing to finish with that, you know? So click again to here, try to do it like that. Going like that. Going the other direction. Okay. And maybe it's, you see that it's broken. So be sure that it's also fix it. So here is fill it. Go to the other side. You see how it is now. Go here. Now it's like this. Okay. See, you can play with it. And mostly the cells. And now it's where the interpretation is here. You need to interpret it. There's a mitochondria here that is more or less in the same plane to the nucleus. It will not be possible. But we know that we have a missing wedge problem, and missing wedge means in the real space that the features are elongated. So this is cell, yes. So for the moment, it doesn't matter. But when we try to select the nucleus, we will see that we'll have troubles. So we have this, okay, and now with this, try again, fill holes, all slices in 2D, refine. And now, hey, there is something you see, click. Why? Because it should be open here. And it's open, and because it's open, it will be not like this. Fill holes, refine again. Now go and see that you already, yep, again, it should be something open. Again, another one open. Close it. Okay. Fine. Now it's more okay. Also, a trick that you could use is to, to smooth it a little bit. Sometimes it works. Go for dilation, volume, or go for 2D, for example, radius 1. Fine, it will be going bigger, you see. And then go for erase in 3D. Fine, fine, fine. It could be used going up and down. Hey, there is some here. Why it's open some way. Or again, fill holes. 2D, refine. Yeah. again, this one open stuff. Again, now it's open because it's standard in 3D, the one I print, so refine. But once you are happy, up and done. Okay. Also here, you see level 1. Or just, no, I don't want to see it. It's okay. Everybody has more or less the cell segmented. Okay. So then when you, if we wanted to go for next level to segment the nucleus, you can go for it and click on nucleus. Ah, nucleus is blue. Sorry, I cannot play with that. It's blue. So I don't want to see this one, and goes for start again. So it's now Supervoxels again, but I would prefer data. Okay. And I don't want to see the Supervoxels. Again, click here, smaller one. See? More or less it fits. So we will use more or less the same trick. Again, fill holes. You can use this slice if you want, refine. See? To fill the pixels. In CETA, or I mean, in to fill this hole is just here, refine annotation level. Click in fill holes, the radius that you want, and this is slice, all slice 2D or volume. For this fill holes, 3 volume is more complicated. More or less is 2D. Then it is all in every single layer of the tomogram that contains a circle, it will be whole. So refine all slice 2D, and then this one is filled, but not this, because it's open at some point here. You see, this is open. Just I close here, and then refine it, and now it's closed. But you will see that's not so nice here. So you can refine it, doesn't matter. Or if you go too much, you can again erase and eliminate some. Again, the accuracy of that just depends on your time or what you want to do. You can select voxel by voxels if you need it. Here, again, select Supervoxels. Okay. And then it's something like this. That's why it makes sense to use here. You see the centrosome, so the nucleus should be something like this. mitochondria, so the nucleus should not be there. And that's interpretation. That's why you need to know. It's not easy to try to segment some volume that you don't know, because you need to put your knowledge inside. The nucleus should be here. You see the shadow, and the shadow here. Fine. You see. Now the other side of the volume. Okay. Holes. See it? If there is some problems, just or some question, just tell me. Okay, I'm just painting to. I want to show you the next, and then I will give you free time to go for the next. Here you see that the nucleus should be here. There's 2 mitochondria here, like a carrot. Now let's go to refine. And this is another trick. You know, if you are not sure that you fit correctly all the slices because you were too fast, you can also do the trick to go for delay. Make it bigger. When you make it bigger several times, make sure that all the structure will be closed. And then again, go for fill holes, all slices. And then another trick, good as I told you, is go for make it bigger in 3D. And then make it smaller. This trick normally smooth the labels. Okay. So everyone has the nucleus as on the. Okay. Again, I don't want to see it to play a little bit, and you can see now, as you can clearly see, this should not be happens, but you see the voxels here correspond to belonged to 2 different levels at different levels. But we want to play now with the mitochondria again. Try to click here. Okay. Let's try to now smaller stuff. You see, that's not good. So what to do? What trick that we can do, reach at that point, and we get the bigger one, is try to go for this, erase this part, go back. It doesn't matter, you need it. Now it's not, you don't need to go for it, but just I wanted to show it. That is possible to go for 2, 2, 2, line. And now create the smaller supervoxels. This was not the case. 2, 6. No, it's better. 1. Explode. Yep. Now we have smaller, sorry. And with this smaller supervoxel, we can continue with the smaller features. That's the good thing of this. So now I want to have a look on the supervoxels that we have selected. And annotation here again. And now, it's a different thing to select mitochondria. So we can use the same trick that we did in the past. So select the boundaries and then fill up the structures. It's a matter of you with just some tricks. And if you want to be disturbed by this, it's easy. We can click. And you will see only the mitochondria. Now there's another one here. It's a matter of you, but normally it's easier to go for the center of something and going up and down. What happens here, for example, I mesh up with this and I decide that this is a mitochondria, for example. Oh, that's not a mitochondria, and then you can erase it, or if it's a vesicle, just once you do that, we'll assign voxels because now they are both in the same level. Clear? Here. You see the mitochondria, you see easily the crystal. For small things, click and then it will select. There are someone typing on the chat. How the labels to the meter, for example, is copied to different slices. It's not copied to different slices. It's just it will extend. I don't know if you know what I mean. Okay. You have it here. You start seeing that's very time consuming. And it's so manual. Some tricks to make our life easier. Again, it happens sometimes that you at some points wanted to go for voxels. You will see it later. So let's go to deletion. Fine. We'll do that. Erosion. Also, you can go in for fill holes, but sometimes it's not what we want at this point because there are some holes here that we wanted to keep it holes. So now it's just a matter of what you want. Or sometimes it's all volume, all slices. No, it feels better. Yeah. It's a matter of you how to want to go for it. Sometimes, for example, let's go to this part. You see the two centrioles here. And maybe supervoxels are not going that nice to that point, so you can select on voxels instead. Oh, sorry, it's not mitochondria, so it's at level. Sun. Go to, for example. No, you need to be careful with that. You know, this is just voxel, so you can select voxel by voxel, not with supervoxels. And with voxels, you will need slice by slice. Because maybe supervoxel are not fitting too much. See, there is something red here. Let's try to do that. But when you erase here, there's something that is not good. You erase the whole thing. You see? You'll not be able to erase only one label. There's something that is not so nice for this software. In Chimera, you can do that. You can erase just the voxels that are not assigned to the level, the label that you want. So let's try here, for example, supervoxels. Click here, and that's not that bad. You see that's not so nice, so you can go for voxels, erase, and you can erase that. See? What happens with the voxels that you need to be so careful. Otherwise, you see when you paint one, but not the other, one, but not the other. Fill up with this, you can try to volume, refine. Let's see, refine, fine.
Javi,
Yeah,
I have a question.
yeah.
Why don't you create one level for each object instead of grouping several objects in one level? Because in this case, you won't have the problem of erasing everything, several objects in one level.
Yeah, that's one option, but sometimes you can create something that are not real. For example, if you have a mistake and you select a nucleus and a mitochondria could be in the same level. Okay, because or is a mitochondria or is nucleus. Or or is a vesicle or is a mitochondria or is a centrosome. So it's a matter of you. You can do it. You can do what you want. It's true. You can do that. But this doesn't. Sometimes it's not real because you can put a voxel to different. You can assign a voxel to different layers, different labels. Sorry. Maybe it's the case, but maybe not. But it's a matter of you. So you can use the trick that you want.
But I don't understand it quite well. So you mean that if you assign one level to only an object, you perhaps are assigning one
One
voxel
second.
to something that is not.
Sorry, Maria Jose, tell me again.
No, you are perhaps assigning one voxel to something that is not what you think that it is, right?
Yeah, it happens. For example, here, if you click here and you go for a mitochondria, oh no, I'm wrong. So, and then I selected, there are some voxels here in red.
Yes.
But now when you go for it, okay, this voxel are erased because they should be only be part of one label. You know what I mean?
Ah, okay. Okay.
They could not be centrosome and mitochondria and mitochondria. They would be centrosome or mitochondria or vesicle.
Okay. Okay.
But
Yeah.
that
Yeah.
could be, that nucleus could be part of cell. But this is something that doesn't matter. So you can do whatever you want on that.
Okay. Thank you.
Okay, you got it more or less how to play with this. So then I will give you half an hour for you play and select this and to play with that in order to create something more robust. Let me show you. I don't know if you did things here. Yeah, something like this, for example. Okay. Here, for example, on this point, I only create a level for cells, and the rest just a part of the inside of the cell. But it's something that is for that you need sometimes to take time to go for the structure that you really need. Okay. Okay. So you would give you 20 to 30 minutes for you to play with this labels, and to mesh up things and create a nice segmentation stuff. Okay. Okay. They are more or less clear how to play with this. But more or less the tricks that we have here, the dilation, the opening and closing, they are not so easy for this, but it's in order to separate or join blobs. Yeah, I don't know, Maria Jose, but it's probably a network problem. Let's see. Still, we are still for a while playing with that. Sometimes it happens that you start segmentation, and where you are in, you realize that you need more time, or you need to change the structure. And it's true that for this, it's not easy to change things. You cannot select a label and send it to another part. There's something that will be nice for this software, but it's not easy. No. So it's well, it's still development. Amira has some nice features. I also like much. It's like you select a label, inside you can play with it. Supervoxels. But then also inside you can play with threshold inside the label that you created, and it will help a lot to eliminate parts of the body that are not necessary. For example, if you go for here and you go here, sorry, and you make it transparent, you see that there are some white stuff that should not be there. And here is not easy. Oh, it's not, sorry, I make a mistake. It's not easy to solve unless you really go for voxels and try to erase this part, or go for a be very careful when you go for it. And okay, but anyway, we will try to do it as much as possible. Still, the things that you need to know is more or less the tips, the tricks, how you handle the software, and what's more or less the behavior. And then the only thing you need is time to do as good as you want and as good as you need. Okay. So once we have all this structure, more complex, more simple, it's you need to know it. What's the label? What's the name? Level 1, the name of the two labels, the level 2, and the name of the 3 ones in that case. And you need to know it. Why? Because for exportation, you will need it. Here down, there's another tab with a lot of prediction and train classifier and annotation that could be, well, there's some part that you could use it if you want. You can play with that. In the SURVOS webpage, there's a lot of you can try with the parameters, but for this course, it doesn't make sense. I tried several times. I didn't get nice numbers. Only the developer of this will be easily get to do these numbers. And for me, it takes less time to do it manually than try to train a neural network. So here there are two small arrows here. You go down. You see the prediction classifier, and at the end there's one of export label. So again, annotate all these, or just save get a screensaver, or sorry, a screen capture, or annotate in a paper. And here, just develop. This we are going to export all the things that we have. What do we have? We have 3 labels, and inside you can select the labels that we want to export. Okay. It's mandatory to select a folder, otherwise the program will be stuck at this point and you will not get data. So select SURVOS, for example, the one that we chose from the very beginning. And then we have here a lot of possibilities for the output. First, you can export the raw data. It doesn't make sense. You already have the raw data, but you can do that. Draw annotations. You can go for this output, HDF files. Also, you can export the annotation files. It will be nice to have it. Segmentation masks. These are the masks. Okay, these are this boundary. Only the masks, so 1 and 0. Okay. And masked data. So the mask, multiply it by the data you want, and it could be the data or all the filters that you have. Okay. Got it? So what we are going to export, all the labels that we have, the masked data. I normally export always the data first, but also if you want to go, you can use the filtered ones. Then for Chimera visualization, I normally get inverted. Okay, as you can see here, this tomogram, the data, the absorption is black. And sometimes Chimera prefer to go for not for association, but just for transmission. So therefore, it's better to make it white. Okay. While it will make our life a little bit complicated at the end, it's better. Okay. And what type of data we are going to export? Again, you can go for it, HDF5, but normally there will two better ones, the MRCs or TIFFs. I normally do both once reach that point. So be sure, that's important, that you select all the labels. Okay. Be sure that you have an output here. Go for masked data and export it. Okay. Also, as I told you, again, go for MRCs, export if you want. And again, the data. And sometimes it's good to export the masks. The masks that could be applied afterwards if you want to with another software, ImageJ or Scipion maybe out. So again, in D4 MRCs, it's just a matter of you. So you can export it if you want. So that's the end of the SURVOS stuff. Now, once reached that point, we are going to go for visualization. Okay. So let me see if there's everything go. Again, we need that. Why we need that? Because this will be the type of data, oops, that we are going to have. The annotation, you know, this annotation 0 means the level. This first 0 is the level. This second number means the level. Sorry, the level. This is the level. This is the level. Okay, you got it? So then, in my case, I only have, at this point, we have only 1 and 2, so 0 and 1. And we have a lot of stuff here. Okay. And we have this type of structure. And we need to know. That's why I told you that you need to know which level and which level it's every structure. Otherwise, it will be quite complicated to go for it. Because you need to load it, and sometimes it's not easy to distinguish. Oh, it's a nucleus or it's a cytoplasm. It will be easy. But sometimes it's not that. It's a small vesicle or big vesicle. Okay? And that's what we have. Yeah, that's clear. Everyone reached that point for exportation?
So I'm exporting the segmentation masks, the masks data, and the row annotation.
Yeah, you can do
Okay.
both, all the things. Here, segmentation and, no, sorry, this is mine. This is the trick that we get for this. So SURVOS, demo data, we are supposed to be there. And these are the things that we have. Annotation data in MRC or TIFF, you see? And the masks are here. Call it masks. Data is data, and masks are the mask, only the mask. Good. Everyone is okay? having the annotation like this, if you keep all this information in the same structure, the same position, it will be nice, because it will allow you to, in the Chimera, to put the colors and everything to one volume and export all this to the whole volumes. I did it at least in Chimera, in the old Chimera stuff. So you create a session, there is a Python file, and then the Python file you can search for names, and all the names will be named like this. The only thing that you need to change is the name of the folder. So if you point to different folders, you will be able to open different different files from different tomograms, and it will allow you to be a little bit faster. We are not going for that at this point, but it's a trick that you could use if you need to segment like that. Huge amount of software. So once reached that point, we can close. Yes. Let me show you just one thing. So if you click another day, you didn't finish. So as I told you, just click here, select the folder, all the subfolders that already created, and then choose. And then you will have everything here. Okay. That's something that you need to know, because sometimes you don't have time to segment every day, or just the software just gets stuck or something, and you need to reboot it. So everything is saved and everything will be used. So now we are here in tools, ls, and then we have ChimeraX. So let's try to /ChimeraX. I told you that I'm more used to Chimera due to the old Chimera stuff, but it's more or less the same. So reach at that point, we can play with this for a while and show you how to handle this type of data, masked data. Yeah, these are the old stuff. I don't know if they have the button. Okay, so then open Scipion, this in data. You remember? Then I think it's better to use all the people the same volumes, but you can use your own if you want. So in segmentation, here in demo data SURVOS, you should have your own segmentations, but I think it's probably better to go for the one that is already there, segmentation end. Say the annotations. So let's go to open first the tomogram. Okay, let's go for one, for example. This is a tomogram. That's the reason why we cannot show a tomogram like that, because it will be out. There's nothing that you could see easily. You can see, you know, more or less distinguish the volume, but it's a mesh. And if we, instead of surface, or volume, sorry, we go for surface, we have this threshold, and this, okay, there's nothing. Okay, there's nothing to play with, and that's why we need segmentation in order to be able to represent in 3D. So close it, open, and go for the annotation files. Annotation 0. Let's go for diff files. Open. Okay, and also it's not easy. Go for surface. No, to go for volume. Sorry, and you see. This is not so nice. It's like yes, you see this point, but we need to go for plane. Yes. That's the cell. So we eliminate all the part in the surroundings that we don't need it. Okay. And there should.
Sorry, I only see a black picture.
So what do you open? The yours or the one that I get in my folder?
The demo data, not
your-
mine.
Mine. So again, let's go for this again. So open in the segmentation end.
Yeah.
Click on annotation 0 data 0.
Yeah.
Okay, open. There's nothing.
No.
Let's go for plane.
Where do I find plane? Sorry.
Yeah.
Yeah. Okay. Now I see. Thank you.
Yeah.
I didn't see where you changed to plane, and therefore I didn't see anything.
Yeah. Sorry for that. Here you have the value. You see now it's more normal. And even there is a trick. I don't know if it works here. Yeah. If you invert the tips, you will be able to visualize in a normal stuff. You know? It's just inverting these two values. Visualize the ortho slice or the plane is good to have this diagonal from one to the other. And you see that it's masked. We eliminate all this part, but this is the cell. We need to know. So let's try to open the other one. Let's go for annotation 1, data 0. Okay, now you can visualize one or the other. So here, annotation 1, data 0. Let's go for plane again. And that's the nucleus. Okay. You see again the same trick. Also, if you can click here and change, okay, you can change the color of these strings, these tips. That's nice because you can, if you want, it will allow you to create some fancy coloring stuff, like green, for example. And you see where are the, see, playing with these values, you can create nice colored stuff as you wish. It's something that it's just a matter of playing with. Define where are the densities that you need to show. Up means increase the intensity of these values. Go down means that going from this to this, it will be not show it. You know? You figure out how it works? But these are surface. And here you see the tensors, both. You see now what's in red, what's not. It's not the same plane, as you can see. So once we have here, let's try to visualize this, no, not in place, now in surface. And that's what we have. And that's the problem to make it positive. I don't know if this is still in memory. No, I think they are there. Sorry, let me 1 second. To go for it. Chimera. Let's try to open the rest of the one. There is a command line that we need to go for it. I think that is here, but it's not. Where is ChimeraX? It's not here in my folder. Oh. ChimeraX. Oh, damn! I didn't found it. I didn't open my own stuff. Let me time. Let's still opening the rest. Let's go here and try to find it. Like this. Up both faces. Up both faces. Let me show. Because now in the other stuff, the old one is just a menu here. But I thought it's there. I forget. Show cap. Cap. Damn it. Cap pieces. Where are there? Volume. Oh, where it is? Shit. Yeah. Sorry, I'm back. Sorry for that. I thought it is in memory, and I thought that this I will get this. As I told you, in the old Chimera stuff, it will be just a menu, but it's not there. So you need to go for this. Okay, volume 0 to 4, or to the volume that you want, the volume you have, false. And that's the difference. Now we are seeing the inner stuff. Okay, and now we're going to see the nucleus, and if we click here, we get in blue. Okay. And that's the nucleus. So we can go farther and lower, and in order to make it smooth, you can go for this. Okay. And that's the nucleus of the cell. Okay, again, open. You can go for the the second one. 1 open. Again, this now, as you can see, this is /3. We'll go for 3. See, now we see all the things that we want. They are probably mitochondria. That's why you need to know. It's on the basical. Okay. And you click on this. You see? Pass the data that you want. In it again. File. Open. And there's sometimes nice things to have. Just like this. Here's the whole volume to see it where it is. So instead of surface, let's go to plane. Instead of this color, click on black and white. Oh no, this is the, sorry. It's here. Sorry.
Okay, my screen totally looks different than yours.
Oh, let's go
I
start
don't-
from the very beginning. We can start from the very beginning.
At some point, I got totally lost and super
Yeah, I'm
confused.
sorry. Don't worry. We can start from the very beginning.
I have one lavender box and one turquoise box.
Don't worry. Close again. Everything. Doesn't matter. Click, 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 click. We are here to show how to do that. Okay. Open. Let's go start from the with the tomogram. Let's try to go for it, for example.
Sorry, I'm still in the process of closing everything.
Okay.
Okay, because I'm not familiar with Chimera at all. That might be the problem today.
Yeah, doesn't matter.
So I open annotations.
Open.
Null, 0, data 0.
Go for this for a moment to start with the whole volume. Okay. Let's use this for example. See it? It will be the reference volume. Open. As I told you, this is not what we want. Go for plane here. And that's more normal. Okay. Got it?
Yeah.
So for the visualization one, this is just the flat tomogram. So now let's go open the masked one. Open. We are going to use 0, 0 will be the cell.
I think at some point I managed to close the whole model, and therefore I only had boxes anymore.
No, I think that this is just visualize. It's a matter of visualization. So go for it. Now you should have 2 here and here.
Yeah.
In the second one, there are nothing is visualized. It's in yellow here. But we will have this, and we don't want to visualize this thing. And in order to avoid this problem, we need to write here in the command line volume, the symbol from, you see here this ID.
Mm-hmm.
So in this case, let's go. If you want, let's go for 2 cafe false. And then you will see just the cell. There's a whole cell representation. At least you see that now we don't have this problem. There is another possibility. Let's click on mesh. Let's go for 16. That's too much. 8. You got it? And you will see more or less. Let's go up, 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 up. And this will be more or less a cell. Got it?
Yeah.
Okay.
I got help now.
Okay.
Someone is in my command line.
Yeah.
First, I was confused, and then I thank you very much.
Yeah, I mean it's complicated. It takes for me time. I mean because this command you need to know it, and I thought that it's in the memory of the, but it's not in my memory, and it's not in the memory of the ChimeraX. So Sorry for that time, but again, go for now the next level. Go for it. It should be the nucleus. Again, we will have this problem. So in order to avoid to be all the time doing like this, or you can go for, you see this now 3, or you can go from 0 to 10. It will be there for everyone. Okay, this is the nucleus. I will love to have this color more normal. Okay, now we are starting to have a look on the cell. Let's go to make it smoother. And now we can use with the surfaces. Okay, we can play with this surface, not only plain. Let's go for the next. Open. We are going in 1, 1. Let's go 1, 2. 1, 2 TIFF. Okay. Oh. So it's here. He's also here. So 4. Okay. Also, we can go again and smash it. And here we are. What are those? See, we are more or less with the mitochondria. Go for red. Okay. Again, another one. Open. 2, 2, 2, 3 TIFFs. Yeah, it's open. What is those? Which volume it is? Oh, it should be just an empty one. Sometimes happens because you wanted to keep the structure of the labels at the same for everyone. Sometimes you get an empty volume. Open, doesn't matter. You see, there's only one line here. So let's go for the 4. 3, sorry. So it is click, 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 cancel. The last one is 3, so the next one is open. It will be the 4. The data 4, open. Go down. Here we have this problem. Don't forget to click here. Now we have something here. Yeah, there's two white small vesicles. So we wanted to have it white. Why not? Why not? I wanted it white. Okay, open. The 5. You forget it, doesn't matter. Go back. 4, yes, we go for 5. Open. 5. It appeared. Yeah. Oh, the same thing, doesn't matter. Yeah, this is one centrosome. Open. Oh, for today it's in green. I love this one in green. 5 and 6. Open. Yeah, the other one. You see it? Open. 7. Open. Yeah, oh, again, doesn't matter. Click again here again. See? And I love this with another color. Like, let's see this one. Okay. And we have more or less our volume segmented. And we can show in 3D the cell and play with this. With the wheel mouse, go up and down. Now it's just a matter of playing with the how we wanted to go for it. We can go with this. Here, I think there's a possibility to rename of this in the past. The name of you want, but I wanted to, in the mesh, sometimes I don't want to see the mesh. So here you unvisualize stuff. Yeah. And there's something that is nice. Graphics. You can play with the views. You can go for this. This is very nice. This silhouette. See, it creates a line. It makes things nicer normally. And but this doesn't make so much sense. Shadows. With different type of shadows. Okay. Yeah. Now this is very nice. And then you can eliminate this, or you can go for this volume and play with the plane that you are represented. Yeah, it will be nice to open everything. That's why you need time. That's the problem. Thing that I did in the old Chimera, I don't want to go for it with this ChimeraX, is to save session. You know, you save the session, and then I don't know if you are in the old past, you can edit this script to allow you to open the next volume with the same names. Changing the folder, but I don't know if you can do this with the ChimeraX. I don't know. I don't want to go for that. It's a bit too complex for the moment. But there's a reason why you need time to go with the segmentation. It takes too much time to manual. It's too manual to go for segmentation to be accurate and everything. It's more or less. You know more or less how to play with this. How to visualize or unvisualize stuff. Yeah, you will have the volumes of this. This mask, this is not big complicated. Even the SURVOS give you this data. I didn't go for that in the SURVOS. Anyway, they will be implemented probably in a future. We have some Python scripts to extract all the data from these volumes, the volume that you have, the surface that you have, of the mask of this, the distance from one to the other, or to one coordinate from the other. Would be nice.